In this video, we'll be going through how scientists currently describe atoms and electrons and consider future directions for research in this field using computational chemistry. Before we get into it, what is an atom? Atoms are the basic particles that make up chemical elements. They consist of even smaller particles, protons, neutrons, and electrons. As atoms are very small, we use scientific models to help visualize and understand them, but we haven't always used the same model. Throughout history, the model of the atom has changed due to advances in technology and scientific understanding. This includes the solid sphere model, the plum pudding model, the nuclear model, the planetary model, and now the quantum model, which we still use to this day. The quantum model is the current model of the atom which we use, developed by Erwin Schrödinger, which describes electrons as waves that occupy orbitals that surround the nucleus, which consists of the protons and neutrons. These orbitals are described as clouds of probability, as the exact location of these electrons cannot be determined. But before, we established electrons were one of the particles that make up the atom. Well, electrons are actually considered both a particle and a wave under wave-particle duality, due to its particle-like properties and wave-like properties. The particle-like properties of electrons include electrons are negatively charged, and electrons have mass. The wave-like properties of electrons include its ability to propagate energy like a wave, which is seen in the double-slit experiment through the production of interference patterns. Knowing how we currently describe atoms and electrons, what is the future of scientific research in this field? Computational chemistry is proving to be a useful tool for chemistry research, as it can be used to model and predict the structure, properties, and behavior of atoms and electrons in various scenarios, simulate many scenarios to gather data from a computer, and interpret complex datasets. Using these applications of computational chemistry, we can use computer simulations to gather further data and interpret data on atoms and electrons, such as the structure, properties, and behavior in many situations to gain a better understanding of them. Thank you for watching.